So we're gonna pretend that the last 3 videos did not have an issue with the recording area, and we're going to try a new project today. And what I want to do is try to generate some 3D landscapes. So why don't we make a folder called landscape, and we'll start up a little project in here. So we're gonna use Raylib to visualize things. So let's make a kind of a hello world for these 3D landscapes. So let's say call it digital landscapes, and we'll close the window. And as far as I know, we might need, okay, so we don't need it right now, but let's have a look. We will need a camera. We will need a camera. So let's actually set this. And then we need the main loop. As always, I should just have like some function that inserts this stuff. For me, I don't like this one. I prefer this one. And let's set up the run script. And GCC, main C. We have to include Raylib source, we have to link to Raylib. We need this and that, and I think we're good to go. Let's do this, go back here and try to run it. We don't have W and H, so now we do, and we run it. We have a nice window. So let's try the following. Begin mode 3D. Now to do that you need a camera. And let's end mode 3D. So let's initialize a camera. So here we have a camera. But we need to set some things on this camera. We need to set the position. So maybe the position can be something like this, like above the XY plane. Sorry, the target can look at 0, and the up direction can be in the Y direction, that's fine. The field of view, maybe it's 45 degrees. And the projection, so camera, that projection. What is that? What are the values? Camera orthographic or camera perspective, I think. So let's use the perspective. And then before we do anything, we should say update camera. Provide the camera by pointer so it can be updated. And now we need to have a look at update camera again. Still we need the mode in here, which I didn't think we would need, but anyway, let's, no, so we need, it's like this, it's related to the movement. So now we actually have a camera, and I'm pressing some keys, and it is actually updating, but of course we cannot see anything. We need to draw something. So let's draw a cube, and I forget what the interface for that is. So here we go. We draw a cube. The position, let's put it at 0, 0. The width is maybe 1, and the height can be 1 as well. So is that one. The color can be, let's make it a red, and let's see what we get. So we don't see anything. We don't see anything at all. Let me have a look at begin mode 3D. So it is just a camera. And the camera here is camera 3D. So let's make sure we're actually looking at the right place. So if we press the Z key, let's set the camera target to be the origin. And now we can actually see the cube. And you can see I'm moving around. The mouse is kind of moving off the screen, so there's a quick fix for that. You can just say disable cursor. Now we have this thing, and we can fly around and look at it from different angles. There's no light. I wonder if there is some thing here. So there doesn't seem to be built-in light sources or anything like that in Raylib, but one of the examples should have that. So maybe we'll look at that another time or a little bit later. But now we have a cube, but to generate our own landscapes, we want to have like a custom mesh, not just something that's predefined like a cube. So I want to make a mesh, and I wonder what kind of functions there are for meshes. So we can load a model from mesh. We can upload a mesh. Uploading meshes takes it to the GPU, so that's important. And we need to unload it as well. We can update it if we change it. And there was also this one, load model from mesh. So let's try to make a mesh. So I have the type definition here, and let me zoom out a bit. Maybe we can have, let's make a super simple one that is just some triangles. So we need we need 3 points like this. And that's going to be the vertex count. Then we'll need the triangle count. So maybe we initialize it down here. Let's say mesh initialization. Okay, so the mesh is something. It has a vertex count of 3 because we only have 3 vertices. The triangle count is 1. Perhaps we don't need to set that. The vertices, I wonder if we can just say vertices like this and point directly to that array. The texture, the normals, every colors, indices, that stuff. Maybe we do want colors. So how about we do unsigned char colors. So we need 3 of those because it's vertex colors. And I think, no, we need 4 per vertex. So let's make 1 red and 1 green and 1 blue, exactly like Copilot suggests. So then the first one will be red, the second one will be green, and the third one will be blue, and the alpha component is just full all the time. So mesh.colors is the colors. So now we have the mesh. Now you have to upload the mesh. Let's comment this thing. So you have to upload mesh. And what it does is it loads it to the GPU and prepares some stuff. So we'll upload it by a pointer so it can update some stuff, some data inside the mesh, and it's not going to be dynamic. And in the end, we want to unload the mesh, and that just takes the mesh like so. So now that we have a mesh, I think we need to make a model. I'm actually not too sure what the purpose of a model is, so let's have a look at that. So a model is a mesh, which is just the raw data, but it also has a position and orientation. It can have several meshes, I suppose, if you want to compose it of several parts. And there's also some animation data. So the only thing we're going to use is actually the mesh and maybe the material, if you want to try to change that, which is how light interacts with the model. So we do that, then we should unload the model at the very end. And now that we have the model, we can also try to draw the model. So we need this function call over here. And let's delete the cube. So we'll draw our model. We will put it at the origin again. The scale can be 1, and we can make it red. I'm not sure if the red thing will do anything. Let's try to make it white because it's a tint. So anyway, here we have our triangle, and you can see that when we go behind it, we don't see it anymore. That's going to be a bit annoying, so I'm going to say disable backface culling. So what this does is when you backface, that's not a function in here. Maybe it's in, yeah, it's in a separate file, so we need to also include this one. So when we say disable backface culling, what we'll get is that when we look at the triangle from the other side, we still see it. So that's going to be quite nice. And just by the way, we see that there is some kind of free error here. So mesh uploaded successfully, unload vertex array data from VRAM. And could it be that it's trying to free this data? That would not be nice. So just to test it, let's say that we will do this. So we need 3 per vertex, and the vertex count is also going to be 3. And then we can have also it's a bit annoying. Let me do something. Type def unsigned char is a U8. So we need a U8 array of colors. And then we can just say vertices. Hopefully Copilot can kind of figure out to fill it out from what we have above. So later on we'll automatically generate this data, so it'll be less horrible to look at. But for now, this should do. So let's see if we still get that error. We still have a double free. So I'm wondering if it's related to this. Yeah, so unload model seems to also unload the mesh. So let's have a look, see if we can confirm that. So at least it frees the meshes. And also here you can see it calls unload mesh. Okay, so we don't need to do that. And then we might actually be able to not do all of this stuff, and we can just use these again. They're a little bit more convenient. No, so it doesn't like that. So now everything closes successfully. Okay, so now we just have a single triangle. Let's try to make it a big plane. So how are we going to do that? How are we going to do that? Maybe if we do something like this. Let's open Inkscape and let's close some of this stuff over here. So we want to generate like a landscape. And the way we can do that is by generating a, maybe if I take this, okay, so we can generate a series of points in a grid like this. I really need some kind of drawing app. So let's put these guys in a grid. And here we go. And maybe I can do this. That didn't work. Any of these alignments that work. So how about these two? And then these two. And then these two like that. And then we can just increase the Y. So here we can imagine that we are making a grid of points like in a completely regular fashion like this. And for each point we can calculate a height, and that will be how we make the landscape. So the mesh needs everything to be in triangles. So what are the triangles going to be? Well, for this mesh here, we can make the triangles, for example, go like this. And let's make those edges red. And we can have one there, and for some reason it decided not to be red anymore. But we can have these. This is one triangle. Then let's duplicate it. That's not what I wanted. Let's duplicate it and let's flip it and flip it. And another triangle is here. So each of these like arrangement of four vertices will make up two triangles, and if we do that for everyone, we'll get like a flat surface, which you might be able to imagine. So let's try to make something like that. So now we'll need like, let's say let's call it landscape width. Maybe we'll have 10, and landscape height, it can also be 10. And then the vertices of that landscape is actually 3 floats, and then in a square like this with this many elements. So now we have to decide what are the sort of coordinates of those guys. So let's have a step size, and we can make a step size of 0.1. That's probably fine. And let's now loop over the row and the column. And you can see here we index. So let's say triangle. No, wait. So what are we going to call it? Just vertex. It's a vertex index. Vertex index is this thing. So vertex index. And the x coordinate is just given by the column times the step size, and the y coordinate is the row times the step size. Now normally in a mesh it takes it takes a triplet of vertices and makes a triangle out of that, but we want to reuse some of the vertices for several triangles. Actually this vertex is part of this triangle, the upper left and the lower right, but it's also part of the upper left over here. And even this one is part of 4 different triangles. So to handle that, we should also have an index array. So how many elements are in the index? Well, there's 3 per triangle. So it should be 3 size of int times triangle count. So what is the triangle count? We have, how many upper lefts do we have? We have the number of columns -1, and we have the same number of lower left, because the upper left stops here, so it only goes out to number of columns -1. So it will be the number of columns -1 times 2, right? So times 2. I'm gonna just, well, it's probably gonna be nice to have Copilot later on, but I just want to think this through, so I'm sure we understand. So this is the number of triangles for 1 row, but then how many rows do we have? Well, again, we have the number of rows -1, because you can see the last one, if we count this row as well, we'll end up with a triangle that's like outside the grid, so we don't want that. So let's do this, and that should give us the indices. Now we need to set up the indices. So let us do this again, and here I think we should just, same reason as before, we should go not all the way. So let's say that this is the vertex, and then we'll have the right vertex, and we'll have the down vertex. So the right vertex we just get by incrementing the column by 1, and we know we can always do that because we're not looping all the way. And this guy, we can get the down vertex by, again, incrementing this. And then we should actually also get the right and down vertex, which is of course both of those things together. So now we can add the 2 triangles. To make things a little bit easier, let's say we'll have like the current index is 0. And then we can say indices, and we need a semicolon. We can say indices current index is vertex. Then it is, I think it should be down vertex and then right vertex. So actually these 2 can be flipped. And then we should have maybe down vertex, and then down, right and down, and then right vertex. So now we have a bunch of indices. Let's try to remove the colors. And here we'll go, this one can actually just be the vertices now. And we should also set up the indices. So let's see, they should be around 0. So I think we can use the thing we had before. So we don't see anything. And that's probably because of the thing with the colors. So let's make up some colors. And it should be 3 size of U8 and a color per vertex. And maybe we just make them pure white. So unfortunately we still don't see anything, which I am somewhat surprised by. Let's have a look at the mesh again. What are we doing wrong? So maybe we have the triangle count. Yeah, we have the triangle count, so we need to set triangle count is actually our triangle count, and this is actually 3 times. Well, the vertex count is not that, it's here. So now we see some beautiful triangles. Now clearly something is wrong. Clearly something is wrong, because look at this. That is not right. As a sanity check, why don't we assert that the current index is equal to 3 times the triangle count? And what are we actually using the triangle count for? That's for setting up the indices. So maybe I'll put that down there. And what is it complaining about? We need stdlib. We need assert. So we do have the correct number of indices and so on. So it's not that. This should actually be an unsigned short. Let's make a type def for that. Forget what that is. Probably it's U16, yeah. And these guys U16 as well. Let's try to run that. So that's very interesting. So it's because we kind of like wrote to the wrong bytes. Yeah, you have to be very careful with the types in C. Okay, now we have a beautiful square. Let us now do something. Let's start by extracting out the x and the y, and let's make the set something more interesting. Maybe we can make the set this function. I think to get that to work, we need to also include math.h. And let's see if we can run that. So now you can see it's a curved surface. It's not very interesting. So to make it more interesting, maybe we multiply this by 3 and this by 5. And slightly more interesting, you can see it's definitely going more crazy now. And we can even just, for fun, let's try to do this, make it a lot larger. And now you can see, it's a bit hard to see because there's no shading or anything. But we have this very crazy landscape. So in the interest of having having shadows, let me check something out. So we can go here to Raylib and we can look at the examples. So just this basic example like this one, I don't think it has any lighting. There's some camera updating. And yeah, there's no lighting here. But I do think there should be an example with lighting. Maybe this one. This is kind of what something like that we want actually. So let's see, it's just drawing a model with a red tint. And there's some rectangle lines, which I suppose is just the grid underneath. Texture, FPS, and the grid. Not sure what the grid is. Model, materials, maps. Material, map, diffuse, texture. So I think it's due to this texture. So in principle, we want the texture from the height map, which is kind of difficult. So what is a texture? Maybe let's try to figure out what the texture is. A texture is something that we can make from an image, if I'm not mistaken. There should be load texture from image. So can we make an image with the heights and then create a texture from that and so load image. We can load an image from a file name, load image from memory. Can we just like create an image? So gen image color. Okay, so we can make an image. And that should probably be the same size as the vertices. I'm not entirely sure, but let's give it a try. So let's call it height image, and then we actually do want to move that up here. So we'll say this is the height and this is the width, other way around. And it can just be black to begin with. So that gives us an image. And what is, in fact, the image format? So image format is something, we don't really know what this means, but because it's just going to be a number, but I'm sure we can find out. So the image format is 7. So probably we have something here. Pixel formats. Is there any other kind of formats? No, there's only the pixel formats. Okay, so 1, 2, 3, 4, 5, 6, 7. So it's like standard 38-bit thing. Which means that we can let's fill in the red channel. So now we need to say height image dot data, and we have the vertex index. So vertex index, and I think we need that has to be multiplied by 4, because we need to step over 4. Well, this is a void pointer, right? So that's it's a bit unfortunate. So let's do U8 height data is a pointer here. So we kind of cast it to a pointer, to the correct type of pointer. So now here we are stepping 4 U8s every time, and the first one, let's set it to this, and the rest, let's explicitly set them to 0. So now it should become more and more red the higher up the thing is. So now we actually need to load a texture. Let's call it the height texture. Load texture from image. And here we should probably say unload texture. And I think we can, this should be like a draw texture. So I think that is worth just trying out. Let's get rid of that and let's see what we have. And this was not called image, it's called height image. And there's a segfault. So that's always nice. So now we need to update this to get debug information. Let's run it again. Let's do this. Let's run. And there is a segfault somewhere, who knows. So let's do this. Let's break in main. Let's run. And let's go. So let's break at 76, continue. No segfault so far. And there's the segfault. Okay, so something goes wrong here, which I wouldn't expect. Load texture from image data. Okay, the reason is, I think, that when you load a texture you need GPU access, and you don't have GPU access until you've done this stuff, the init window at least. So that turned out to be right. And now we can see we have this very nice texture. Wonder if we can scale it up. Draw texture. Texture. Source. Maybe this one. So we'll get the height texture again. The position can be 0, 0, 0. No rotation. And the scale is maybe, let's scale it up by a factor of 10. And let's see. It's a bit too much. So this is the texture, and that should match the height of of the actual triangles. So now we need to do something like they do in this example, where we set the model material to be that texture. So there's something here that is interesting. It also unloads the image and unloads the texture, so maybe we can do something similar. Like here we don't need the image anymore. We can get rid of that. It should still run. So model, let me actually just copy this stuff. But I'm still, yeah, there's still no light. So I suppose that is fine. Maybe we need to update the shader or something to get light. Anyway, here we are, and it's just completely black. Completely black. So something happened. Something happened. And it could be because this texture has a different dimensions than what I'm expecting. Draw model. There's also red. I wonder if that's probably has nothing to do with that, but we can try. Yeah, that did nothing. There's also a draw texture, but I think that is just drawing this thing up here. I think that is drawing that. So, in the interest of understanding what the hell is going on, let's go to the example, models, and which example was this? A height map. So that's this one. And gen mesh height map. So apparently that is, I thought that was like a function specific to this example, but apparently it's something in here. Generate a height map mesh from image data. And it also takes a size. What is the size? Oh. So that's very convenient. Let's try to use that, because we already have the image. So let's call this like mesh 2, whatever. And we'll take the height image, and the size is like the extent in like world coordinates. So let's just do something like this. And then when we make the mesh, no, so that is already the mesh, sorry. So that is the mesh. And then we don't really need this stuff. We can just say load model from mesh. And we can take mesh 2, and we can just be happy. So let's just, for the sake of making sure we deinitialize everything, let's do this, and let's see if that works. So it does actually work. It's a bit crazy to look at, so I wanna do this and this. So we have succeeded in generating some kind of crazy thing. What if we say x minus 1/2 to the power of 2, and let's see if that looks like anything. I'm a bit surprised. I thought the okay. Let's also do this. So here we have a function that looks like this. And that will be centered around x equals 5 and y equals 5, which with this step size and this width and height, that will be in the center of the mesh. So we got something looking like this. A bump in the middle. So maybe that's the best way to generate these landscapes. We just generate a bunch of heights, and then still though, I'm a bit sad that this doesn't work. So maybe we should take a look at this gen mesh from HeightMap. So is there perhaps something called rmesh, rtextures? So I'm actually gonna go into here so I can grep for gen mesh HeightMap. All right, here we go. So it looks like it's actually doing exactly what we were doing. Look here, there's 1 quad for every 4 pixels. That's what we were doing. Allocate some stuff. Colors are not there. Then we loop over rows and columns. The vertices are set. There's some scale factor, but whatever. And the height is just from the height map. And this is the second triangle. It's just duplicating some data. I wonder if that's our problem. We don't have, maybe it's this texture coordinates. That's what we need. We need the texture coordinates. We need the texture coordinates. So what actually is that? Texture coordinates, and it's just the texture coordinates, not the texture coordinates 2. So let's set that up. Text coords. And what is that? That is two components per vertex. And that is simply like the relative progress along the dimension. So let's see if that now works. And this still doesn't work. Still doesn't work. Is there anything else we need here? Maybe it's not a... well, of course we should set the texture coordinates for it to have any effect. There we go. There we go. Nice, 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 nice. Maybe we will... This height data is now just used to make the texture. So we can actually do... This is a U8. We can do 1 minus set. Probably. It's a little bit jarring. It's a little bit too blue. A little bit too blue. Maybe something like this is okay. So I think we're gonna cap it here. So basically the difficult part is make a mesh and with some interesting shape. Here we have this function, and you need to set up the vertices, the texture coordinates, and the indices if you don't want like too much duplicate data. And then you just use the built-in functions in Raylib to get it to the GPU and to load a model that you can draw, and then you're good to go. So maybe in a different video we'll try to make some interesting shapes using some noise functions, or try to generate something that looks like a mountain range or something. So I'll see you in the next one, and bye bye.